All right, hi everyone. Welcome to this special talk organized by, by Bethesda Data Science Meetup Group. For those of you who are new to the group, Bethesda Data Science aims to showcase advancements in data science, machine learning, and related fields through informational sessions, networking, and social events. Recently, we've been focusing on research projects, but a lot of you have expressed interest in learning about tools to help enhance your data science work. So tonight we'll be featuring the second of a series on tutorials on practical software solutions to make your work more efficient and impactful. So as a research scientist, I often find myself developing proof of concept applications in Python that run on my local computer. Now, the problem is when I want to get that into the real world and share with other people, either I have to give them a Python script to run, which is not practical, or I rewrite it in JavaScript so it runs in the browser, which is also not practical and time consuming. So what I'd really like to do is have a tool that takes my native Python code and then turns it into a web app. Is there a tool like that? If the answer was no, we wouldn't have a talk. But luckily, the answer is yes. It's called Streamlit. Streamlit helps you convert your native Python scripts into web apps and with interactive elements, and it's really great for doing work in teams. Our presenter tonight is Matt Zamora. Matt studied neuroscience at the University of Maryland, College Park. Today, he's a senior application developer in the pharmaceutical industry with an interest in full stack development. So his talk tonight is going to be on how Streamlit can be used for collaborative science. And it's particularly interesting for me because he'll be presenting a motivating study, which is a case study on behalf of Team MCH, which is a collaboration between MoCo Makers, DMV Petri Dish, and HacDC. In this case study, the team tackled drug discovery for neurofibromatosis, which is a rare genetic disease. And they use Streamlit visualizations to help bridge the communications gap between the technical and non-technical team members. So a couple of announcements before we start. If you haven't already, please fill out the survey at the link that I'll post in the chat. It's anonymous and helps us bring you talks that you're interested in. Our next meetup will be on June 25th, which will be a collaboration between the world famous Steve Chen. Where is he? Somewhere back here. And we're coming soon. He's the developer of Code and Coffee series. This meeting is going to be the inaugural meeting of the Montgomery County Code and Coffee. Details will go out probably sometime next week. And also Bethesda Data Science will be having a summer party in July. So stay tuned for that. And without further ado, I'll turn it over to you, Matt.
Thank you very much. Just checking, can everybody on the internet see my screen and hear my voice? Please comment in the chat. All right, appreciate it. Thank you very much. All right, so we're going to go ahead and get started. So what we're going to cover today is a little bit about the project. As Itai introduced, there was a competition. It was Hack for NF. It covered a rare genetic disease called neurofibromatosis. We'll go into a little bit of that. We'll get to how we applied Streamlit, the interactions in the team setting as far as discovery and research. And then just a little bit of summary. So going into the details of what actually did we do. So the Children's Tumor Foundation had a hackathon. It's one of those rare biomedical hackathons. In 2022, we had 3 local area volunteer teams representing MoCo Makers, DMV Petri Dish, and HacDC. We ended up winning 2 of those, so go DMV area, we did really well. And it included 1 grand prize, which was the drug discovery prize. So that came with a little bit of money, a little bit of incubation, and that incubation was really important for us. That was a 6-month period of getting a little bit of extra attention. Someone says there's mute the in-person. Okay. Oscar, please let us know if the echo is still there. Is that any better? Okay, awesome, thank you. All right, so this was really fun. We did this just because we enjoyed the challenge and we were looking to collaborate with other groups in the area. Definitely calling out that this is a perfect fit for Bethesda Data Science. So next year we will be reaching out and you guys will be involved in these competitions and we're going to win again. We're going to do better next year. So you can expect that tap on the shoulder from at least us reaching out to you and seeing who's interested. All right, so again, just a little bit about who's involved, just so you're aware. MoCo Makers is a DIY tech group. We also have DMV Petri Dish. Ulysses Santa Maria is in the room with us here, and he is coordinating a large collaboration effort across Maryland and the DMV area to bring together the bio groups and the tech groups and to just see what we can do as far as shared resources, collaborations, entrepreneurial development, and education. HacDC has been around for a long time. They're fantastic. Our machine learning experts largely came from that group. Capital Area Biospace was a collaborator with us. We kind of used them as a springboard for our initial meetings. We have a special call out for Paul Zamora, who is our chief scientist, unaffiliated but retired, and just really smart guy. And then 30 volunteers, international. So we had people in India, we had people all across the country. One of our primary collaborators is in Chicago. So it's a whole new world, very exciting stuff, but a lot of brain power if you can tap into it. So I'll pass through this, but the slide deck I'm assuming will go out and you'll have access to this for future usage. All right, so what did we do? So again, we fielded multiple teams. 2 of the teams won. Those are the 2 I'm calling out here. Drug discovery for neurofibromatosis 1. We filtered small molecule data from quantified high throughput screening using statistical interpretations. We identified trends in responsive compounds using network analysis of pathways and to understand mechanisms of action and find patterns and relationships that would inform treatment options. We then demonstrated a more detailed application of drug sensitivity screening for malignant forms of NF1. Keep in mind that this was the description for what we went live with. The competition was a 3-week competition. Since then, we've had 6 months to really reinforce that. So we've gone further than that as far as building a web app, which we'll demo, built in Streamlit. And then the other group I'll just call out, they did some really cool stuff with natural language processing. They had large data set. They had 3D visualizations for TensorFlow. And that was led by Gabriel from HacDC. And this really cool project. So what is neurofibromatosis type 1? It's a rare genetic disorder. It affects the NF1 gene. It produces a protein called neurofibromin, which is a tumor suppressor and a signaling regulator. It's one of those involved in many pathways kind of proteins. So it's hard to say the one thing it is, but it is very much in the class of the oncogenes and something that is affecting downstream known oncogenes and cancer regulator proteins. So it predisposes patients to having tumors, primarily in the nervous tissue. It's resistant to therapeutics, and there are poor treatment outcomes. Additional signs and symptoms include hypertension, scoliosis, learning disabilities, ADHD, and others. We'll go into that a little bit more detail. It affects 1 in 2,500. So it is a rare disease, and that presents a problem, right? The primary premise of the Children's Tumor Foundation is that it is a lot of people, but not enough necessarily for big pharma to really turn their heads. So there's this opportunity for citizen scientists, for open scientists, and for communities like ours to really push this field forward and get it more attention, get it more research. So there's that kind of value proposition of how we can help out as non-industry, but still make a big impact. So there isn't a lot available for this. Again, being a rare disease, there is only one option. It's an MEK inhibitor called selumetinib, and it's only for pediatric patients and only for those pediatric patients that have inoperable tumors. So there's nothing on the market FDA approved for adults, and there's one thing for kids, and it's not that great. It kind of gets less effective over time. So it's still a wide open space as far as what's available. So becoming familiar with neurofibromatosis here on the screen, we have a number of types of symptoms. The symptoms vary. There isn't the one thing that neurofibromatosis is. There are hallmarks, and of course there's clinical diagnoses. If you have a set of a number of factors, you were diagnosed with neurofibromatosis, it's of course something that they can do a genetic test for and validate that way as well. These are called café au lait. They're the brown splotches, and the most common ones and the ones that have probably the biggest psychosocial impact are these tumors. So they can form generally, they're generally associated with nerve tissue and connective tissue again, and they can be very disfiguring. You could literally have thousands and thousands, or you could have none obvious. It's possible for you to only present your tumors on the inside. So you could look conventional and then, on the inside have a lot of discomfort and pain. Now, the benign tumors can still be fatal. They can impinge on important tissues. They can become malignant. In fact, 15% of benign tumors end up becoming malignant. So the number one concerns generally are the psychosocial impacts, the disfigurement, and the pain. These can be very, very painful. And other than the physical symptoms, there's cognitive things I really do want to call out. Brain tumors, seizures, learning disabilities, things cardiovascular. Again, the NF affects a lot of types of things. It's known to impact the neuron growth and the formation of dendrites. So it affects a lot of different systems, and it's because of that the phenotypes vary, meaning the types of presentations for the symptoms vary dramatically. People again can present normal or with a large number of tumors or with learning disabilities, those kinds of things. So why that presentation? Why that kind of variation? Well, of course, it comes down to the role of the actual protein. So neurofibromin plays a critical role in a variety of protein complexes, including signaling pathways, cytoskeletal interactions. It's an oncogene. So the way I think of neurofibromin is it acts as a raft. So if you see that there's this receptor here, normally this is a growth factor receptor, but it could be a number of a type of receptors. And what's happening is that there's growth factors out here. Things like you cut yourself, and things are in the area prompting the formation of scarring tissue. So there's growth factors in that area. Those are signaling the cell, and what's happening is the growth factor comes, it turns the signal on, which is basically this GTP state. So guanine triphosphate. It's very similar to ATP, if you've heard of that. That's the main energy molecule within the cell. And basically, you have 3 phosphate groups in the on status, and then you have 2 off in the kind of the dormant status. So what neurofibromin is doing is it's helping cleave one of those phosphate groups. It's important to think of it as a complex. It alone is not the catalyzer, but it provides catalytic stabilization. So there's multiple things that come together and form a region that's able to do catalysis. So this is all the background. What we ended up doing to give you this preview is let's make sure that, yep, that looks good. Oh, no, screen share. Let me get screen share up. Okay, so what we have is a Streamlit app that was useful for research. And it's useful not just for research, but for presenting our results, because ultimately we're not going to do this alone. We're going to collaborate with other principal investigators and with pharmaceutical industry. So what we have, just briefly, and I'll go into this slower later, is we have a set of compounds. These are all the drugs that that went through the screening process. For any given drug, you can select it, and then we'll get some updated values. So each of these is a different cell line. And so what you're seeing is concentration going to the right, and then response is the y-axis. And response for these is cell death, because basically what we're giving them is chemotherapies. So we're giving the chemotherapies, we're seeing which is the most responsive chemotherapy, at what concentration was it responsive. So now the shape of these response curves is very significant. We go into a lot of that because what happens with these screening panels is they don't know ahead of time what's going to work. They prescribe a set of concentrations they guess might work, and then they just try them out. This is a brute force method. Now, you can look at the data you get, and if you see that it's clipped, or it doesn't have a good sigmoid curve, then you're not representing the data very well. You're not capturing the right concentrations, or there was something wrong in the well, the cells got disturbed or something. Something went wrong and it just didn't represent good data. But fundamentally, this is a way for investigators beyond our team to look at this and kind of go closer. We have some reference charts, and then we have a good deal of interpretations, which I'll go into a little bit more detail coming up. But it's basically the premise that these interpretations are dynamic, and the investigator can set confidence intervals for some of our parameters, and the data will update. So if this R squared, for example, has to do with the shape of this. The higher the R squared, the more strict we are with the shape of these. So if I'm a little bit flexible and we'll have a little bit of bad data, I can have this be really low. Probably you wouldn't be all the way at the high end, but we're looking at, for example, in our paper we're publishing around 0.8. If we can hit a sigmoid-like shape that's at least 0.8 line of best fit, then that's good for us. But again, different investigators might have different principles or different biases for how they do those parameters. So let's go into a little bit of, about Streamlit and about that app. The next thing that we'll look at is a few examples just to give you more flavor for Streamlit. All right, so again, one thing about the Streamlit app is it has the ability to change the theme. There's normally a default light and a dark theme. So light side of the force, dark side of the force. I'm always dark side of the force. And what you have is basically, this is just random other people's examples, but you get the sense that you can have a bit of interactivity and you're communicating something, right? And you have pretty liberal, interpretation of what you're actually doing. Very much dynamic. For those of you paying attention, there's a little bit of a load process between. There's a little bit of running. It's actually running the Python, refreshing the view, but there's some good interactivity there, just out of the box with the Streamlit app. Let me get this out of the way a little bit. All right, and then here's another one. So the reason I show this one is if you've ever worked with Tableau or with any of the visualization dashboards, you should get a real Tableau vibe here. So yes, like this can do the same things that other visualization tools can do, like Tableau or any of these chart builders. But it's running in Python. You have the superpowers of Python. So if you wished you had Tableau, but a special function to do this special type of statistic, you can do that. You have that kind of superpower. And then this is a really cool example, just showing, I'll do Rockville, Maryland. And it's just showing the diversity of what Streamlit can do. There's a number of widgets that I'll get into in a second, but basically it's not one thing. It's not just a data science tool. It's a rapid prototyping tool, and the way it works kind of behind the scenes a little bit is that you have these elements that you can bring in, And the elements vary dramatically, of course. I look at it as a toolkit. It has a really large toolkit. They also use the term Swiss Army knife, but basically, to be efficient, you can just find something that has some cool features that you like, and pull that in. This is just an extras bundle, so this isn't the main app, but it just shows some of the things that you pull in. And so, for example, this button, it's a one-liner, and you're going to see that commonly, that all of these widgets are one-liners, and you're just pulling them in. So that's really cool. So let me go back to screen share. Yeah, what's your question? Yes, we have a demo of that. Now, again, it's Python, right? So you do anything Python can do. But the short answer to that is yes, because this has really been biased and influenced by data scientists. And they're very AI heavy. So short answer is yes. Strict answer is it's not technically the same thing because it's a visualization tool, but you can do anything with a visualization tool. And we do have an example of that.
You kept saying that it's Python. How is it being hosted?
Python. There are multiple ways. I do get into one example of hosting it. The example that we use on our server is Docker. So we have a Docker running on a Linux instance, and that just is really simple, dirt simple to get this thing running based on the code. But it has a server in itself that it can also run. All right, so getting started, Anaconda. Now, I have to admit, I am not an Anaconda advocate. I like to have local system Python like we used to back in the day. But there are strict constraints around not just Streamlit. Streamlit goes up to, I think, Python 3.11. But when you work with data science projects, you're going to encounter constraints. So it's not always your constraint you have to worry about. A lot of times it's the projects that you're working with, their constraints. So just bite the bullet, get Anaconda. It'll make your life easier. Once you have Anaconda, which basically is just a standard set of Python packages at a standard version of Python, then you can do pip install Streamlit. Very, very simple. All right, so we're going to go ahead and jump into the code demo. This is a repo. Again, this link will be in the slide deck that will go out. And this is something that we'll go ahead and get set up right now. So let me share my screen. And we will jump over. So right here, I have our Anaconda. Let me go ahead and change over to that. Okay. All right, so to run a Streamlit app, very simple, Streamlit run, and then the name of your primary file. So looking while that boots at the basic structure, there is generally as little as one single file, right? So we have app.py, and you can have multiple pages. If you think of it like a notebook, you can kind of get that. We'll have that in our demo. But really, really dirt simple. I mean, if you look at what an app start to end looks like, it's can be as little as 2 lines. So it's dirt simple, these things. And you just have to launch it with the Streamlit tool. When you launch it, you'll see that you'll get this localhost IP address. Go ahead and boot that. Oh, it in fact already opened it here. So this is our app. We'll go through this demo right now. So hello world, everybody's friends, hello world. We have, first of all, importing Streamlit as ST. That's the conventional shorthand for the Streamlit. st.write. Write is a loaded function. It can write a bunch of different data types. It's very robust, but of course, it's really good for our little friend hello world. A few things about it. Again, we have some settings out of the box, the light, the dark. Now, another thing about this, so this is running a local instance server. We can make changes on this real time. So I'm going to go ahead and open our demo. This is the real code, the one running the thing. And right here we have that st.write, hello world. This is a live demo. Go back, and you'll see up here, source file changed, rerun, always rerun. I'm just going to do it manually, but you can set it up always. So there's some degree of simultaneous code monitoring. It's not perfect, as nothing ever is, but it does have you know, some good real-time features, which is really great for prototyping, lots of fun. So all right, the next thing is just HTML, import HTML. So of course, you can do anything you could do on a normal web page in Streamlit. And this is how. There's a markdown element. You're passing it your string and just a little flag for whatever arbitrary HTML you have beyond the basic stuff. And then hopefully you're already starting to get a sense for the flavor of Streamlit. Again, toolkit, there are a bunch of these really handy widgets and interactive features. So this link is the link. This is the link for all the widgets formerly for Streamlit. So you see quite a number of things: title, header, caption, code, LaTeX, which is fantastic. We use that in representing some of our formulas. Data frames, tons of input widgets, the sliders, the text areas, the dates, camera input, file uploader, just a ton of things. So if anybody's ever done UI design, this is it should feel familiar. Anybody who's ever done game design or event-driven design, this is an event-driven framework behind the scenes, but it is so magical that you don't need to worry about those events. It's very, very simple. They made it for the proverbial dumb data scientist, which is I love it. So tons of things. Again, now to characterize the nature of this project is about being effective. It's about being fast, and it's about leaning on the magic. It's not about customizing it to the nth degree. Now, they have logical things. Almost all of these have an on-click callable event. So again, event-driven design. So you can hijack your system when something happens to do something else. We have a demo of that, but it's not the emphasis. The emphasis is getting up running, having something effective, letting the magic work for you so that you as a data scientist or as an investigator, you can work on the bigger problems, basically. So let's go back to our code demo. So introducing some input elements and some responsiveness. So here you see that our value is updating. So how awesome is this slider? 110% awesome. Thank you very much. You know, basic default values, the label, the min, the max, and the starting value. And then look at what it takes to make that interactive just using the variable. That's magic, and that's beautiful magic. And what I mean by magic is you don't have to pipe the things together to make them simultaneous. When one is updated, it will be generally noticed across your whole application. And that's very handy. That's something that the real strength of Streamlit is the ability to have dynamic interaction, variables that propagate. You just use the variable as you would hope to in Python, and generally it's got that the latest value for you. So here is a little app for an SVG color picker, because why not? Because we can. So just the ability to have a color picker and do something with it. Here's the code. So there is a color picker element that we're just using. We are using conventional Python to open a file. We're opening a SVG file, and we're just reading the contents in. We are doing a replacement of the color, and then right here, this is the magic. This color variable that we're doing this replacement is, dynamic. Like, I didn't have to do anything to glue the color picker together to the function that does the color replacement. It is just doing a replacement based on this variable. This variable is changing. It knows to rerun the Streamlit app interface on change. So a lot of that magic of the interactivity and again, just using the variables as they are, very powerful. And then the markdown is we're just rendering the HTML string coming from the SVG. So very quick, super powerful way to just do a random thing I cared to do. Let's take that one step further. So we're going to work with this guy, and we're going to have a little prompt that will tell us the opposite color. So like imagine inverting a color. So we'll go ahead and change a color, just adding this part up here. You picked this color, perhaps you want the opposite color. So a good example is if we go ahead and we pick white, FFFF, perhaps you want the opposite 000. So what we're doing here is it's the same thing. I wanted to demo using the onChange thing. You're passing it what's called a callable. A callable is basically the name of a function to do something. And then these are values that well, yeah, so you're passing the name of a function, the function runs. So if we look at what that function is doing, so first of all, for it to calculate the opposite color, it has to know the current color. So going to the current color, we are getting this color key value. This color key value is the value of this color picker. And so we're basically giving it a reference that we can touch it on the shoulder and say, hey, what was your value again? And we're getting that here. We're getting the session state of that thing that we gave a key to. And then now we have that dynamic value. We're able to do the invert and just the updating. The actual alert is a .info. For any of you who's worked in web design, there's .info, .warning, .error, the common alerts that you would see at the top of the page. So let me now take us a little bit deeper to an example that does use AI. So for AI, we have another example called FidoBook. This code is a little bit proprietary, but I'll share it with you guys here. Oops. So we'll do Streamlit, run Streamlit images. All right, so this is a real world example of me being an entrepreneur and thinking of a business idea. And it wasn't my idea, but the premise is being able to have a cartoon image created of a dog. So you have a dog, you have a picture of a dog, and you want a cartoon version of them. So I was like, well, Stable Diffusion can do stuff like that. but let me play with Stable Diffusion. How can I do that quickly? Well, Streamlit was the answer to how can I do that quickly. So if let me just demo what you have here. So this application lets you enter a prompt, upload a source image, enter a prompt, and dog wearing a hat, and generate an image. So what's happening behind the scenes is that it updates. First time you run something, it downloads a bunch of metadata. I will come back to this example if it's going to take a long time, but I will. Let me dig into the code a little bit because that'll be useful, and hopefully you can guess what it will be doing. So we work with Stable Diffusion with these diffusers. You have a pipeline that you're feeding your prompt into, and what we have is we have our friend the Streamlit import. We are setting up. Most of this is environment setup for working with Stable Diffusion. So we're specifying which GPU, which model of Stable Diffusion we want. Now this is running locally as opposed to a lot of the ones that run on the cloud. In that regard, setting up the GPU, doing garbage collection, working with RAM, very important for this kind of image. It's kind of like 32 gigabytes of RAM and up. Because we are working with generative AI, every time we run it, the results will be different. We're going to set a seed so that the random value is consistent, right? We'll get consistent results that'll allow us to tweak our things. Now, we're setting up here two of our Streamlit elements, two sliders, an inverse fidelity score. The fidelity is how close to the image do you want the derived image to be? Do you want it to be very loyal to the original image or very different from it? And then guidance scale is how close to the prompt do you want to be? Do you want to be very loyal to that prompt or different? So we're setting up the seeds, and now we have this new element, the file uploader. So working with file uploads is like a one-line thing. It's the easiest I've ever seen for file uploads. You get the uploaded file as the output, then an input prompt and a button. So boom, we're off to the races. If the button is true, so just leveraging that event state, then do something. And the thing that we're doing is ultimately this magical line right here. Take one image, convert it to another image based on an input prompt. And then what we're doing here is displaying images. So you'll see that we're displaying the original image, and we're displaying 1, 2, 3, 4 times running this prompt. So we'll circle back to this, but what we'll get with this is the results of the of running that generative AI on this image. So we'll circle back to that. All right. So let me go into our demo a little bit deeper. Let me get the screen share going. Okay. So our data was high throughput screening data. What I want to call out is just the nature of it. Basically, there's one row per drug, and you have 11 of these data points. The data points here represent the amount of cell death, and it's measured with luminescence. So the less luminescence, presumably the more cell death, and concentration of the sample. So at data point 0, you had this effect at this concentration. What that lets you do is build a dose response curve. So what you would expect pharmacologically speaking is as you increase the dose, you see more of an effect. The effect depends what the effect you're measuring. It could be cell death, or it could be the activation of something. what we did as far as like the proprietary part, not proprietary, but like the innovative part of our project was we looked at the scoring. So conventional scoring is very similar to this. You're looking at a reference line and you're comparing it to something else. So basically we took non-tumor as a reference and then tumor, and we gave the same drug to it. And we saw, was this drug more effective in the tumor versus the normal non-tumor cell? And so what we're looking for, of course, is a chemotherapy that's selectively deadly, killing the tumor versus like your healthy cells. So the conventional way to do that is to look at this, what's called this AC50. AC50 is the concentration at 50% of your dose response. So it's just this middle, and the middle is a really convenient place to compare to otherwise equivalent independent drug samples. So we had another premise that we wanted to cover, which was the sense of effectiveness. So yes, you can see what is more sensitive or more resistant relative to a reference by looking what's left and right. But the effect size of it, the magnitude, that's actually indicated by the asymptote. So the height between this lower asymptote and this upper asymptote has information in it that we're calling effectiveness. And we capture that. We take those two values, we do the ratios with the test effectiveness versus the reference effectiveness, test AC50 versus reference AC50. We get a single value score. And that single value score is the heart of our calculation. So now we're gonna go a little bit deeper on the neurofibromatosis stuff and that specific example. So a little bit of notes about this app. There is a password. You guys can log in and access this. It's important when you're doing these kinds of projects to think about the distribution mechanism. We want it to be public, but we don't want it to be too public because it could be work in progress. We don't know the status of it. And could be that you have restrictions on your data. So we're running this on Docker. You get a port number and you have to allow that through the Docker. You have to allow that through the server port. And I have some code coming up on how to create a Streamlit password and use that. And then we have an auto deployment. So tied to our version control. So when you push your version control to your GitHub, for example, it will auto deploy that to the server. So deploying to servers, updating what you're actually presenting to people it's all code heavy and should be very familiar to developers. So let's switch over now to our get screen share up. All right, let's switch over to our Streamlit app. Let me see if I have that. Think this, okay, so it's just now started. So let's take a minute to take an ooh and ah at our generative model. Now, we didn't set these to be very high, so we might not get very interesting results. But we'll see what we get. So, all right, not too much interesting. You will notice that there are some differences, and it's a bad prompt. So I will leave it at that for now, and we'll circle back to this demo later. But let me go ahead and switch us back over to the NF Streamlit app. Wait. All right, so this is the app that powers, actually, I'm going to use the server. I should have thought of that. I'm going to use the server that we have, which is good old HTTP. just because I was not all the way configured with HTTPS, but you can get that. Now, again, password, very important in practical terms when you have data, sensitive data. All right, so basically we have interactive elements over here that adjust stuff on the side. I think I'm having a weird caching issue. Let me switch to private browser, see if that helps. Okay, well, I will go based off of the original view. All right, so again, the point is to have the interactivity for an investigator and to approach your data in business useful ways. So what we're actually doing after you get past the basic curves, which again we're filtering for R squared, which is how closely sigmoidal are they. We're looking for investigational trends. We don't know exactly what we're going to see yet. There's a bit of just fun to play with kind of interactivity. It was useful during early investigations. The key here is that who's building this and who's it for, and what are you communicating? So we're bridging the divide between what the scientists need to see, which is they need to see this, and what the data scientist is able to do and how they can help. We're solving that communication between the coders and the non-coders. And we're recreating the algorithm. So whereas our primary score was derived by the scientist did not have the capacities to visualize and present. And what we found was there was overlap during the investigation process between what the data scientist was doing to kind of dabble or explore the data and preserving that in a way where not only could the investigator look at it and be like, oh, well, that's new. How about we go down this different angle? Or how about we try something else? But also then at the end of the project, now we have a full top to bottom deliverable we can hand off. Give me a second. There we go. All right. So I won't go into it in too much detail. The code, again, is available on GitHub. But again, the ability to create the sidebar and to basically top to bottom just go down and recreate our algorithms and have that interactivity just be out of the box. The thing to keep in mind here is that things like this where it's clickable, that wasn't coded. We didn't make this clickable. That's out of the box because this was made by data scientists with that that data investigation bias to their base tool set. Very powerful. Again, the basic premise behind it is that it is a lot of one-liners. A lot of this is in the reference material for the Streamlit app. And we have useful information here on how to set up both a Docker and how to set up an automated deployment so that when you're pushing this, it goes from your version control to the server. What we're going to call out, let me get the screen share set up. What we'll call out here is this is how you add passwords. It's something pretty much you can drag and drop into your application, very basic. It comes down to setting up the password and then checking it. And if it's true, you continue into the bulk of your application. Otherwise, you return this password incorrect error and you're kind of stuck in this part of the app. It's not high-end security. but it is down and dirty as is most of the things with this project. So basic lessons learned and working with the cross team. Everyone has an almost published strength weakness profile. Lead scientist loves Excel, can't program, but has read hundreds of research papers. Biologists, excellent writer, non-coder, hates math. Project manager admits to being the most clueless in the room, a little of everything, fake it till you make it. We have our senior AI ML software type, visualization guru, of course, the person who innovated on the Streamlit for us first time around, knows the math, explores data, has trouble framing it in an industry standard way. And that's part of what we're bridging with Streamlit. Bioinformatician knows what to do, has explicit approach in mind. And then the junior devs are task oriented. So when looking at that, the communication is the bottleneck. So scientists drive investigation, but when the data processing becomes a bottleneck, they get stuck. Or worse, Excel macros. We had a problem where our lead scientist created a macro that was so long, was the heart of the project, and then of course he copy pasted errors or columns wrong. Now that was okay for early phases, but as we go out and we're publishing our results, we're recreating everything in the Streamlit in that kind of everybody agrees this is what we're doing kind of way. So we had to redo the macros. Now the data visualization team would explore the data, try many things in Jupyter, but it was hard to capture from a finalized data. So Jupyter, of course, it's running locally on the developer system. It's not fair to assume that most scientists can run Jupyter. I know as data scientists, we get a little bit, oh, every scientist should learn how to, do Python. That's not fair. I mean, if you work with people in other industries and these cross-collaborative teams, that's not a fair expectation. Now, if you can give them a URL, a website, and you say, go to that website and look at the data, they can do that. Everybody uses a browser. So it's bringing the barrier of entry down to the realistic level that non-coders can be very contributing and productive, and having that back and forth where they're also informing what you're visualizing. And regardless of who is driving, iterate quickly and publish your latest work. So having the developer visualize something and say, here's where the data is, having the scientist in their Excel world saying, create this chart I just created, that's effective communication. They're showing each other what they want, and that's very effective. So other little jokey thing, Gabriel Atley, the primary guy who did the main Streamlit app for our project. First rule of XML, don't parse XML. That was a funny thing. It's true, just turn it into, I think we ended up with a JSON object. Here's a set of useful links. Again, the most important one being that API reference that has all of the little widgets you can bring in. And just a few more, the app that we're publishing our data is this NF Streamlit one. And there's more about our project. If you're interested in the neurofibromatosis side of it, here at this link with this event, has a bunch of other links on it. Thank you so much. So the slides are available at this website. Again, we'll make sure you get them in some way. I guess, Itai, are we open for questions or?
Yeah, we can take questions in the room, and if anyone online has a question, you can post in the chat, and Matt will get to it.
Thank you very much.
So the question is, how do we input data into the application? And the answer is it's Python. So any way Python can. Now, that's the silly answer. The fact of the matter is that it's very intimate with Panda. So if you can set up a data frame in any way that you want to set up a data frame, you're off to the races. This works intimately with data frames. In our example, we are loading Excel or CSV files. So we have CSV files, they're on the server, or they're at least in a known location, and we publish our files. But any connector could work. It could be a live database, it could be a file. Yeah, they're not my strong point. I'm not an R person, but these are comparable to most UI building tools and plot tools. There are plots in here. Basically, this package was conceptually developed after the industry got to where it is now. So with the Jupyter, with the matplotlib, with those things that conventionally you're doing for chart building, this has that frame of context and says, well, let's do the next thing. So a lot of the assumptions you would have as far as how axes work, what charts are available, how can I work with my data in a data frame, a lot of that's transferable. It's just a little bit easier because they make it a single line function now. So the question is, did I code this locally and then push it to the server? Yes. You can have the streamer run local and then push that equivalent code to the server. You can set it out however you want it. You could test straight from the server, but no, we would run it locally, get it to a good point to share it with the team and push it to the main branch at that point. Let me check chat to see if there's anything there. Ooh, lots of stuff. Let's see. Will the recording be available? Yes. Is there an issue where too many data creates a ton of latency? How does caching help this? So this is going to be a constraint of the server. Now, there is a front-end aspect. I mean, you're literally working in a browser, so you're not going to render a million lines in a browser, or if you do, you're going to use pagination or something elegant. But yes, it can be a conventional issue, but it would be the same issue you'd have with any browser-based tool. I won't go too much into caching. It's generally not strictly needed for most projects. That normally, if you're working at the charts level or the data summary level, you've already done the processing. The processing, though, is going to depend a lot on the server specs. Yeah, we'll try and repeat the questions. Let us know, Mark, if you have any issues with that. And then this is great and useful for a machine learning engineer like me. I also have tasks of creating a UI for the non-technical audiences. Yes, speed of UI generation and collaboration, because that's really the bottleneck with collaborating is how fast you can do it. I mean, you could have written a standard HTML page to do everything abstractly, but the point is that this should feel familiar when you're working with these Pythons. You're starting at the top, you're working down, you're working with functions, you have variables, they pass around, and you're just out of the box getting that interactivity. So the speed that you can issue a prototype is the value point of Streamlit. Again, the caveat being it's not that high end, dial it in to pixel perfect precision of exactly what you want. There admittedly is some bending over backwards if you go too much outside of their wheelhouse, but this is a very robust platform. So most prototypes are going to be A-okay. With interactive charts, do you find Streamlits to be sufficient, or is it better to do something like Dash? I find Streamlit to be sufficient. Streamlit has a lot of interactivity native. So, you'd be hard pressed to find a chart that they don't have good support for as far as style. And again, the best place to look for that is going to be the reference gallery, which is going back this slide right here, this Streamlit.io gallery. A lot of the demos that we gave at the start were from that gallery. Question is, would you want to automate the selection process either by setting ranges of inputs or ranges of results you expect? Automate the selection process by setting ranges of inputs or ranges. So yes, we did do that. In fact, so for our algorithm, we had sliders, and the sliders affected the formula. So going back to the formula, briefly, I know it hurts, but the quality of the data that we were like using when we were looking at these sigmoid curves. We had a slider for like how sigmoidal was it, and that would pass through. So from a modeling perspective and from an AI perspective, we all have hyperparameters that we're optimizing. The interactivity with those sliders lets you play with those hyperparameters easily. Of course, depends on your server, what it processes, but this is, again, just general purpose Python on the back end. You can do anything you want. It's just a matter of, on the UI part of it, being able to quickly set something up where those hyperparameters are available to you as a simple variable, a text variable, easy to work with, super simple. Okay, any other questions?
Yeah. Oh, okay. Not the-
Okay, fine. Do you walk through like the backend one more time? How do you create a Docker and
Sure. Yeah. So the Docker's okay. The Docker is very simple. As in, if you've worked with Dockers before, the premise of a Docker is it's a virtual machine, and they come when you download them pre-configured. So there's a Streamlit Docker that's pre-configured to run it. You just have to pass it your code file. So generally, I have to go back into it, but generally with Docker, you're setting a shared, well, at least the way I do it, you're setting a shared folder between your host operating system and the Docker. So I set my Git pipeline to deploy to the OS like it was normal, just a normal deployment. And then I have that mirror between the host OS and the Docker where I'm sharing a folder, the code is there, the Docker is configured to look at that place for the code. Again, you're just pointing it to the root app.py or whatever for your Streamlit, and you do expose the port. So if you notice on our actual URL, I don't do anything magical with that port. Again, very lazy. I expose the port. So this port 8501 was passed out of the Docker instance into the OS, and then passed out of the OS over the internet. And so it's just, we're allowing that direct connection from the internet into the Docker image on that port number. And so we're just exposing it. Now, there are more advanced tricks you can do to get rid of that, to have it just be a standard .com. You can do magical redirects behind the scenes. So it appears as just a normal website, but again, I was lazy, so I kept the port number there. You can, however, specify whatever port number you want. And then there was a question in chat. What was the question? I think I have them all.
The question was, with interactive charts, do you find Streamlit to be sufficient, or is it better to use something like Dash?
Yeah, we have that one. It's better to use Streamlit. It has that variable passing, and it has the magic, the interactivity, and the ability to just capture the variables from your user prompts very easily.
Cool. So there's no other questions. I'll take the last one. What's the topic of your next hackathon? And will you be using Streamlit? But I probably know the answer.
Oh, hey. Let's talk, let's collaborate. I will say that the NF competition happens once a year. So we're hoping it's not up to us, but we're hoping they have it again next year. We're happy to collaborate on a hackathon. We have one potentially coming up on what we're calling Spark Day, which is just a project-based symposium, for lack of a better word. The last thing I'll call out is we have a lot of cool things happening in MoCo Makers world. One of them, just to chill for a minute, is we just launched a crowdfunding campaign. So we have this memory foam pillow that one of our members here in the room, Tim Murphy, has created. So this is the first day it's live, just launched today. It's the only reason I'm bringing it up, but there's a lot going on in our space, and we're happy to support tech entrepreneurship, including stuff like this CAD-based design. So thank you so much.